Hello everyone. In today's lesson we're going to go over section 6.2. 6.2 covers integration by substitution. But first let's begin with a warm-up. Let f of x equal cosine of x squared. Find f prime of x. In other words, find the derivative of f of x. Go ahead and hit pause on this video so you can work on the warm-up problem. Okay, now check your work. First, let's identify u and f of x. Remember that u is the inner function, in this case x squared, and f of x is the outer function, in this case cosine of x. Now let's take their derivatives. Remember that in the chain rule the outer function is not used anymore. Now let's put our derivative back together. F prime of x equals 2x times negative sine of x squared. Cleaning it up, we get f prime of x equals negative 2x times sine of x squared. Here's a thought. If f prime of x equals negative 2x sine x squared, when f of x equals cosine of x squared, then the integral of negative 2x sine of x squared dx equals what? Cosine of x squared. And don't forget your constant of integration. Recall that if we take the derivative of our answer, we should get whatever is in the integral. And if we take the antiderivative of the integral, we should get our answer. Okay, so let's begin. Evaluate the integral of 3x plus 1 to the power of 4 dx. Just like the chain rule, we first need to identify u. We said that u is going to be the inner function. We will take the derivative using differentials. So du equals 3 times dx. Integration by substitution is much like putting a puzzle together. The pieces have to fit. We will divide the last equation by 3, and there is no need for the middle equation. And now we are ready to begin substituting. We will remove 3x plus 1 and substitute it with u. We will now remove dx and replace it with 1/3 du, which is the equivalent form of dx. We have now successfully transformed our initial integral into an integral in terms of u. Notice that the integral is now easier to integrate, where u is going to always equal 3x plus 1. Using our integration skills, we have 1/3 u to the 5th power divided by 5. Let's quickly simplify to get 1/8 u to the 5th power. Now we will substitute our original equation of u, which is 3x plus 1, to get, and don't forget your constant of integration. Analyze our original problem and analyze the answer. What is something that you noticed? Because we will be discussing this in class tomorrow. Again, at any time in this video, feel free to pause so that you can reflect or analyze anything that's going on in the problem. Try to follow along this problem as I will just be showing visuals.
Please hang up and try again.
Again, feel free to go ahead and rewind or pause the video so that you can analyze any situation. Again, look at the initial problem and the answer because we will be discussing this tomorrow in class. Let's try out another problem. I'll give you some time to think. What do you believe you will be in this scenario? Alright, let's see. Take the derivative. Let's begin substituting. Notice now there's an extra x that is being multiplied to dx. This is good because if you notice the integral has x dx as well. Now we can continue with our substitution. Follow along because we are going to use some algebraic manipulation to simplify the integral. Now that we have successfully simplified as much as possible, we can begin to integrate. Plus c. Now let's simplify and resubstitute our u. Let's try another one. Again, please follow along as I will only be using visuals. Okay, final problem. That way you can enjoy the rest of your evening. Let's begin with identifying u. Remember, that's the inner function. Let's try something out. After you're done hearing me talking, go ahead and pause the video. Try out this problem on your own. And then go ahead and compare your work to the work that is on the screen. You see, you got this. Now go ahead and reflect about all the work that was done with these problems. Please write down any questions you guys might have and feel free to ask them tomorrow in class.